first, I'm going to let the polynomial be fx. So fx will be representing x to the power of 3 plus ax. The remainder when fx is divided by x minus 2 will be f2. And the remainder when this is divided by x plus 1 will be f minus 1. And according to the question, these are equal. They are going to be sharing the same remainder. So f2 will be 2 to the power of 3 plus a times of 2. This is going to be equal to minus 1 to the power of 3 plus a times of minus 1. So we have 8 plus 2a is equal to minus 1 minus a. Bringing this over to the left-hand side, this is 3a. This is equal to minus 9, and we will be able to solve for a. A is going to be equal to minus 3. We will solve this equation, and the first thing that I'm going to do is to let the left-hand side be equal to the function g. So I'm going to let gx be equal to x to the power of 3 minus 2x squared minus 4x plus 3. And with a bit of trial and error, we will realize that g3, which is this to the power of 3 minus 3 squared minus 4 times 3 plus 3, this is equal to 0. And this tells us through the factor theorem that x minus 3 is going to be a factor of gx. So it's a factor of gx. We're going to find the other factor, which is going to be a quadratic factor. And to do that, I'm going to take gx and I'll divide it by this factor. And we will be expecting a 0 for the remainder. But let's go for a long division to find the other factor. So I'm going to take gx, which is x to the power of 3 minus 2x squared minus 4x plus 3. And I'm going to divide this by its factor, x minus 3. So here is going to be x squared. So x squared minus 3x squared. X cubed minus 3x squared. So this minus this, we will have a x squared minus 4x. So this will be plus x. This will be x squared minus 3x. And we will have a minus x plus 3. And here, if I were to go for a minus 1, then multiplying by this, we will have a minus x plus 3. Perfect, because we're going to be getting a 0 for the remainder, which, like what we were saying, this is what we have expected since we are dividing this by its own factor, which means that gx can now be re-expressed. If I were to let gx be equal to 0, which is this to be equal to 0, it can now be re-expressed in terms of its factor. One is x minus 3, the other one is a quadratic factor, which is x squared plus x minus 1. This is equal to 0. So x is equal to 3. This is one of the roots. And the other roots can be found by letting x squared plus x minus 1 to be equal to 0. To solve for this, I'm going to make use of the quadratic formula. So it's minus 1 plus or minus square root of positive 1 square minus 4ac. So it is this divided by 2a. And this is going to be minus 1 plus or minus square root of 5 over 2. So we have the other two roots. One of them will be minus 1 minus square root of 5 over 2. And minus 1 plus square root of 5 over 2.